Okay, now let's solve question number 3, which is a question of momentum and impulse by the looks of it. Let's see. A particle P of mass 3 mkg and a particle Q of mass mkg are at rest on a rough horizontal surface. The distance between P and Q is 1.4 meter as shown in the figure. All right, an impulse of magnitude lambda Newton second is now applied to P in the direction PQ. Immediately after the impulse is applied, the speed of P is 5 meters per second. Find lambda in terms of m. Okay, the first part is fairly simple. Just remember that impulse is basically nothing but change in momentum. Okay, now what causes change in momentum? Could be the change in velocity. Okay, because if you're talking about one specific object, obviously the mass of that object is not going to change unless it combines with some other object. But if the velocity changes, then obviously there is a change in momentum, and that's basically what impulse is. So technically, impulse is mass times the final velocity minus the initial velocity. Now, if you go back to the question, and we are just talking about P right now. Okay, so forget about Q. So P, as you can see, is stationary. So that means this is what the situation looks like. Here's the horizontal surface. Here's the object of mass 3m, and it's not moving. That means the initial velocity is 0. Okay, and then because of the impulse, of magnitude lambda n, there is a change in velocity. Okay, and the new velocity now becomes 5. So that means v is now equal to 5 meters per second. Okay, and this is due to lambda. Okay, now, so what do we do? Well, here's what we're going to do. Lambda, which is the impulse, is equals to change in velocity, change in momentum. So momentum is mass times change in velocity. So change in velocity is 5 minus 0, and we're supposed to find out lambda in terms of m. So that means lambda is equals to 15m, and that's it. That's your answer to the first part. Okay, now let's have a look at part B. Part B says, okay, it's a 7-mark question. Immediately before P collides with Q, the speed of P is 2.5 meter per second. The coefficient of friction between P and the surface is mu. Find the value of mu. Okay, so a good idea would be to first take a picture of this. So let's copy this. Let's move it to a fresh page. Okay, and also, just so we don't have to do a lot of back and forth, let's copy the question also. So let's copy this, and bear in mind that this is a 7-mark question. Let's put this here. Let's put them side by side, so we have plenty of space. Okay, now, so we know that this is a rough surface because there is friction. Okay, and whenever there is friction and the object is moving, so that means this is the formula which at some point we will have to use. That is, F net is equals to mass times acceleration. Okay, and at the moment we're talking about particle P. Okay, the main focus is on particle P only. Okay, so this is what we're talking about. So F net is basically all the forces that are acting in the direction the object is moving, okay, or the driving force, minus the resistive force is equals to mass times acceleration. Now notice that there is no constant driving force. There is no constant force which is making this object move towards the right. Okay, there was just an impulse and that's it. There is no constant force. Nobody is pushing this object constantly, or there is no string which is pulling this object, anything like that. So that means the driving force is 0. However, there is a resistive force which is equal to mu times r. Okay, that is basically the frictional force. Okay, so the resistive force is basically the frictional force. So 0 minus frictional force equals to mass times acceleration. Now what's the mass? Remember, we're talking about P, so the mass of P is 3m. Okay, and what's the acceleration? That is a. Okay, now what about r? So r is the normal reaction force. Now this object will be exerting a force of 3 mg to the ground, and the ground will be exerting as a reaction a force of 3 mg on the object as well. So that means the normal reaction force is equals to 3 mg. So 0, actually we no need to write 0 again. So minus mu into 3 mg is equals to 3 ma. Okay, now minus 3 mu mg is equals to 3 ma. And keep your eyes on the price, we're supposed to calculate the value of mu. So 3 and 3 cancel, m and m cancel. That means mu is equal to minus a upon, or you can think of it this way, let's not skip a step, that after cancelling everything, we're left with minus mu is equals to a, or a is equals to negative, mu is equals to negative a. Yeah. But we're supposed to find out the value of mu. Okay. What we're supposed to do is we're supposed to find out the value of mu. Okay, actually negative a upon g, just realized. Negative a upon g. Yeah. Minus mu times g is equals to a, which is why mu is equals to negative a upon g. Okay, now we have two unknowns over here. We know that the value of g is 9.8, that's a no-brainer, but where do we get the value of a from? Well, if you think about it, if we look at how p has moved, so notice that it moves a distance of 1.4 meters. Yeah, so because right before collision means that must have moved a distance of 1.4 meters. And notice that its initial velocity, okay, as soon as it starts moving, its velocity was 5 meters per second, okay, and just before collision, okay, just before collision, the question tells us that its velocity was, let's have a look at the question. Just before collision, its velocity was 2.5. Okay, so that means just before collision, its final velocity was 2.5 meter per second. So what can we do with the help of this information? We can find out the acceleration. How? Using the formula 2as is equals to v square minus u square. So 2a times the distance, which is 1.4, is equals to v square, which means 2.5 squared minus 5 squared. So let's work out a. So this would be equal to minus 375 upon 56. Okay, so just use your calculator. Minus 375 upon 56 is the value of a. Now once you have the value of a, you can find out the value of mu. All you got to do is simply multiply this by minus and then divide by 9.8, and you will have the value of mu, which correct to 3 decimal places is equals to 0.683, and there you go. That's the answer to part B. Okay, so I hope it's clear. It was lengthy, but I don't think it was a difficult one. But it's not the end of the question, definitely. There's part C also. Part C says, immediately after P collides with Q, the speed of Q is 2.1 meters per second. Find the speed of P immediately after the collision. Okay, now one very important thing to observe over here is that we're not told anything about the direction. Meaning we're not told the direction in which P will move after the collision. Okay, it's possible that after collision it's moving towards the right. It's possible that after collision it starts moving in the opposite direction. You know, it's possible that once they collide, P and Q both head in this direction. It's possible, obviously Q is going to move towards the right, there's no doubt about that. Okay, it's not possible, it's practically not possible for an object to hit it in this direction and get this object moving in this direction. But P could potentially hit it in this direction and then start moving in this direction. Okay, Q will obviously move towards the right only. So keep that in mind. Now with questions like these, I have a specific way of solving them. So I like these before after columns. So we have two objects, one is P, one is Q, the mass and the velocity. So the mass of P is 3m, the mass of Q is m. The initial velocity, the velocity right before collision was 2.5, okay, and Q was stationary, so that means its velocity was 0. After, obviously the mass remains the same, so that's 3m and m. The velocity of P, however, is unknown, so we're going to put a plus minus. Why plus minus? Plus minus V because direction is not known, and there's nothing in the question which suggests that it's going to be moving in a certain direction. And Q, we're given that has a velocity of 2.1. So now we multiply. So mass into velocity, so that's going to be 3m times 2.5, 3m times 2.5 plus 0 is equals to plus minus 3mv plus 2.1m. Okay, now let's work this out, see what do we get. So this makes it 7.5m minus 2.1 m divided by 3 m is equals to plus or minus v. Okay, so v is equals to, let's work this out, 7.5 minus 2.1 divided by 3. So we're looking at 1.8. Okay, notice that m and m will cancel. In fact, let me just add an extra layer of working to show you. So 7.5 minus 2.1 will be equal to 5.4 m upon 3m. So m and m cancels. This is equal to plus minus v. So once you work out the value of v is equal to, it's equal to 1.8 meters per second. And there you go. That's the answer. This is what the question wanted. And that is the answer to part C and also the end of this question.